action. Alrighty then, so, and he says that, and it's like, let's make sure I got all my notes and stuff up. So where we left off, we were drawing like little lines. Did you actually, I know you were off just testing that while we were setting up. So yours still builds and runs and everything?
Yeah, I can still make lines. And
yeah. Oh, are you off on the other screen or something?
Oh, really? Oh, yeah. Okay, that's probably because I'm sharing an application window and not the actual.
Oh.
Uh-oh.
Well, that's okay. Maybe we'll just do it this way, because I mean, you can see what you're doing. I can't see what you're doing if there's any errors, but you can see what I'm doing. So, and I'll just try and mirror your code. So we can just keep going if you want, unless you
Okay, that's fine. No, that's fine. Yeah,
have
that's
that
fine.
under control. Okay, I'm just gonna, if you've resized that, I'm just gonna adjust that. There we go, smashing. All right. Right. So what we wanted to do, this is going to be a little bit of maths anyway. So I'm gonna have the whiteboard up and draw some stuff. So you remember that, actually, yeah, I'll run that again. So what we wanted to do is, you remember that if we like zoom in, we're zooming from the origin up here, and you know, if we pan around, it's like I want to zoom in on like this corner here. Zoom in and it's like, oh, we're zooming at the origin, we're just flying around like crazy. So what we want to do is zoom in on the specific point that we're mousing over. So that should be fairly straightforward. So let's go and look at what that looks like. So let's say we have just a coordinate system, and maybe we've got like a circle just up in here. Whoops. And we want to zoom in on the circle. So say our like point of zooming is here. And so the question is, how do we zoom in on that red dot rather than like zooming around the origin? Because you can imagine if we zoomed around the origin, that would get like twice as big, but it would also go like twice as far out. It would be out here. And what we actually want is it to appear here. So we want it to stay centered around this red dot. And the way that we sort of want to go about doing this, so we have a number of operations. Like we can make a translate matrix, we can make a scale, we can make a bunch of other ones, but sort of you sort of imagine that those are the two that we're actually going to use here. And so the way that we sort of approach this problem is like, well, what combination of these two operations would we do to get, you know, from there to there? And the answer to that is, what we do is we would...
I would guess that we would translate from the origin to the location of the dot and then zoom from there.
Yep, pretty much exactly that, although in reverse. So what we do is we want to translate this dot to the origin. That's step one. Step two is we'd scale it. So the end result of step one is like that, with our little red dot in the middle. So, and then we want to scale it, is step two, and we'd end up with graphics are very pretty today. We'd end up with that after step two, and then we'd want to translate it back to over here. So it's like we would move that back there, and that's step three. And so, you know, following that through, we get step one, step two, step three, and that gives us this overall transformation. So we've got three operations there. So we have translate, scale, translate.
Can you briefly explain why we need to do that rather than, for example, zoom in place, and then move it, or like what I said was to translate it to the origin and then scale it. I guess because you just have to move it back. Yeah, that makes sense.
Yeah. So I mean,
And visually, it makes sense to do that. I'm just not sure why the other order of operations would cause like manipulated end
so
results.
so what you're
Like
saying
that
is
it doesn't look right.
why don't we do it the other way around? I think what you're saying is why don't we do it like let's draw it up here. First we scale it, which puts it out there somewhere, and then we translate it back in like one step. So it's like, in fact, you're quite right. That would be one step. So we then translate it as step 2 back to there. So we can do that, and the reason that we don't, like, we almost do that in a certain sense, because all of these operations, the one that goes up there, the one that goes down there, and the one that goes across, are equivalent, let's say. Like, you get the same end result out either way. The reason that you'd want to approach it in this way is because it is simplified. And I'm just trying to think how you would, like, because obviously to do this step, like, this translation vector we know because that's at like our cursor position. It's like it's negative C for cursor, let's say, and this is positive C for cursor. So that's really simple.
Yes, right.
Going that way around. But this one here, the question is, what is this vector? And you'll probably find that it is some, it's like a scalar of C, like, we're translating it by negative C times S, or 1 on S, or something like that. And so you could work out the maths that way, and you get exactly the same result. The only reason you do it this way is just maybe because it might make the maths a bit easier. And you tend to,
that's fine.
Yeah, you tend to do it when you have like a scale. It's like, well, I want to scale around the origin because that's really easy to reason about.
Mm-hmm.
So let's think about what this particular operation means. So we know that we have this affine transformation matrix. It's like A, B, C, D, and translate X, Y. So that should be familiar at this point.
Mm-hmm.
And so let's, using that sort of thing, let's draw out this series of steps. So we have a translation first. And so we know that looks like, the identity matrix at the top, and the augment will be CX. Sorry, it will be negative CX, negative CY.
Right.
And then we're doing another operation, and you also should be familiar with the fact that we can chain these together. So this is going to be scale. S looks a lot like a C. That's going to be scale X, scale Y, 0, 0, and then in theory, like 0, 0, 0 in the augment. So this should be familiar, like that's the scale matrix. With me so far?
Mm-hmm.
So
yep.
Now what we could do is we could chuck another translate on the end and fill that out. But we know that the translates happen after the matrix, and we can like
I see.
We can look at the code for that, and we'll be like, here's the code for that. Get inverse as matrix. Yeah. So we do the matrix transform, and then we just chuck the translate on the end. So we actually can just shortcut that and just be like, well, we'll scale it, and then we'll translate it by CX, CY. And so that's already, we've compressed these 1, 2, 3 operations down into 2 matrix operations.
Right. Yeah.
And all we need to do there is, go through and do the multiplication. So we know that like this multiplied by this, oops, what did I do? That's going to equal just that on its own. So that bit's trivial. Yes, that bit is trivial. So that's just sx 0, sy 0. And then we have to figure out the translation. So we know, and we wrote the code for this, that when we multiply two affine transformation matrices here, the resulting translation vector, the augmented part of the matrix, this one here just gets left in as is, whereas this one here basically just gets processed through this matrix. Does that make sense? Does that sound familiar?
Yeah, I mean, if we did the math, it would be what you're highlighting, and
yep,
I get that.
Yep. So that's So this is obviously A, and that's B. So then we just have to multiply that through. So, and because this is a scale matrix, it's really simple because we can ignore this business as well. And I'm just going to go ahead and write this out just below because it's going to get a wee bit bigger than the space I've left for it here. So the translation is going to be negative cx times sx plus cx, and the y component is going to be obviously the same. It's going to be negative cy times sy plus cy. And hopefully, if I've done my maths correctly, so that just lives in here. This operation that we've come up with there, that one, is equivalent to this one here that does the basically scaling around a specific point.
Right.
So why don't we first of all try and implement that just on its own, just to check that we've got the maths right. Because if we don't have the maths right, obviously we have problems. So this is like, we could leap ahead and just make it interactive and stuff, but let's try some hard-coded values. So let's find our camera, get camera, and just simplify a bit. Let's kill the rotation. And in fact, yeah, let's comment out all of this, and that should just give us just this scene. And let's say we want to zoom in on this, let's say this yellow point here, because it's about halfway on the screen. So what we want to have at the end, I'll turn that back on just to sort of manually generate that, just to demonstrate it. We want to see, we want to see a scene that looks a bit like this. So we've zoomed in on this yellow point here. With me so far?
Yeah, you want to add a fixed value for where that is?
Yep.
Like to zoom. Okay.
So we'll get rid of the interactive camera for now, and we'll keep using the camera. And let's figure out where that yellow line is first of all. Oh, it's probably going to be. Well, that makes things a little bit interesting. Yellow is okay. Yeah, it's just scaled by 4 on the x-axis, so it's at 400 to 50. Yes. So that's where the bottom of that yellow point is. So how do you feel about giving this a go just on your own? We can, and I think what we might want to do is let's try programming it as, this business here, or in fact, these 3 steps, and then we'll compress it down into just 1 step, hey?
Right. Okay. Right. Okay. So if we did it like translate, scale, translate, the scale is going to stay the same because we're still pulling the value off of the mouse. Out of whatever the zoom factor is from scroll state. So that's fine.
Yep.
And then I guess, this isn't right now, and then this.
Yeah. Let's just comment out the interactive ones for now. We'll put them back soon.
Yeah, understood.
Yep.
Okay, so in this case, then, let's see. In my brain, it makes sense. What can I do? Thing. So CX and CY is target, right?
Yes. So that
so
was,
we need to
yep.
But the origin is, is the origin fixed? Or is it actually it actually is fixed? It's 1 and 1.
The origin is always fixed. We always move around the origin.
Right. So in this case, it's 0, 0. Okay. So
I'll bring the diagram back
but
up.
the camera position is relevant, though, is it not? Because we're
So right now we've got, if we comment out all of that and we run it, we've got just a identity camera. That's the identity matrix. That's world space is just getting splattered out onto the screen. We're not moving it around.
Right. Okay. Well, if I can ignore that, then I'm sorry. I'm stuck on whether I probably should be keeping this translation relative to the camera position and then doing the negative CX CY.
So what I want to say is, let's ignore where the user puts the camera for now. For what we want, our camera doesn't exist.
Right. Dirk?
Yeah, and we haven't specified how much we want to zoom. Let's zoom in by, say, 4 times.
Oh, we're really going. Okay, we're really going.
Unless you. Actually, we could make that interactive. We could make it the zoom value.
That's the one thing that won't change the axis. We use the mouse wheel, so we might as well leave it in.
Why not? Let's just use the zoom value because we can then scroll it to test it, and so let's see if it works.
Right. It does. On my computer, anyway.
I've done something horribly wrong. That's all right. Here we go. That's better.
So that's the thing we want.
That's what we want to see. So this is now equivalent to if the user's holding their mouse cursor there and zooming in and out. That's what we want to see in the end.
Right.
So let's think about how we can. So I did actually want to keep the stuff that we had before. So we have create, scale, zoom, zoom, and then create, translate, camera position. So let's comment out our little test and bring back the code we had before. I'll leave the rotation out for now. That's looking pretty good. So now we're back to where we were, and we can right click and drag it around, and we can zoom around the origin.
Right.
So now the thing about this is these are like our inputs. This is that's what we want to do. So it's not like we can just oh, he zoomed in. Well, we kind of can. We can we could do things like, oh, we zoomed in, we'll add that in there. Oh, they zoomed in again. Oh, they zoomed out. And all of a sudden, like, we've got to either make a list of these, or we have to start accumulating in the transformation in the like floating point values in there. And as we discussed, that's not something you want to do, because like you'll get floating point inaccuracies, and it just becomes a bit of a headache if you try and do it that way. So does that make sense from the last time we talked about that?
Yeah, it does.
So these are the operations we have. So we have to fit this somehow into that. And fortunately, that's exactly what we came up with here. Because we can see that when we combine these three operations into just one, we have a scale that happens first. And as we mentioned just before, we have a translate that happens next, which happens to be, fortunately, that. And of course, this is something that we like talked about. Like we said, oh, you can do it this way around as well, but like then if you zoom in, the translation becomes detached. And this is another reason why you might want to do it that way, is because when you flip it, into this form here, it works. So all we have to do now is say,
just manipulate the transformation that's in that.
Exactly. So every time we hit zoom, we want to do the equivalent of this. So, and now we know the equivalent of that. So let's go program that in. We need to find it, which is where is the code for this? Oh, here, scroll state. Okay, so scroll state is where we're doing the zoom. So we're actually not getting an event here. So maybe we want an event, because right now we're just reading off the scroll state to get the zoom value.
Right.
So we're gonna need to know how much we're zooming by, because we know that this here requires knowing the scale factor. So we have to pull out the scale factor, which is this variable here. And so we can just, I think we can just slap that in a function. That's probably good enough. Scroll state is an integer.
Normally we would just do it twice, right? I mean, for one line. We would just copy paste that when we need it.
Yeah, like that's not too bad, but the reason I'd take this one out is because there's constants in there. It's like, well, we want to make sure that, if someone goes in and later and is like, oh, I want that to be 4.
Right. Okay.
That they match. And I mean, what I am doing is I'm keeping this like a static function. So this is stateless. It's not like it's going out into the state and grabbing this, because that starts to, that's really where you get the problems. Like if I did that, you can see how pulling that out might make things a bit worse. Hopefully. Does that make sense?
Yeah. I mean, scroll state is already being stored, so it's wasteful to store it twice anyway, because you're storing a thing that you can functionally derive anyways.
Well,
yeah, I get it.
Yeah. And the thing is, like, this is like, this doesn't add all that much to the sort of complexity of the program. This is almost like a mass function, like cosine or something. It's like,
right,
here's our simple mathematical function that relates the amount of scrolling to the amount of zooming. So we're doing this, and all we have to do now is add the translation. We have to get an event. Okay, we need an event because we want the camera to move every time the scroll changes. So we actually have, like, there's
Oh, I see.
yeah, there's no way to relate the value of this to a position, because the
Do you really want a Windows event, or are we just going to do like a pending rule or something? I
yeah,
don't really know.
this is like if, you know, ms.scroll wheel value is greater than or equal to 120.
Right. That's one tick.
Yes, except, okay, so this is where it gets a bit interesting, because and this is sort of like, I know you're like, oh, we can do it this way. You'll remember that last time I was like, okay, we're going to accumulate into the scroll state, and then we're going to be like, if the scroll state is greater than 120, or if it's less than or equal to 120, we want to know. Come back here. We want to know about it, so that we can then do some stuff. And like, so I actually shortcutted this process, I guess, last week, because, you know, I knew that we're going to have to go and get a event here. So I'm going to point out something here, and that is the scroll wheel value is an absolute value. So it's you actually do need to accumulate it to get these events.
Why does it say that it's a cumulative value since the game start?
So this is the absolute value. So like the first time you click it, it'll be 120. The second time you click it, it'll be 240, and it'll stay that. And yeah, and this will just keep firing as you zoom every single frame.
Yeah, we don't want that.
Yep.
Okay. What about the fact that they're both using the equals thing? They're both going to fire if it's 120. That's okay.
That's because I made a mistake. There we go.
Oh.
Good catch.
Scrolls minus. Okay, I get it now. Okay.
Okay.
Sorry, I'm
No,
slow today.
take your time.
New keyboard. I'm learning how to type on it. It's not my favorite keyboard right now. Okay.
So
Events happen in here. So once we get a tick, we're going to.
Okay, so let's actually modify this a bit, because now we don't necessarily want. I guess we can go off scroll state, if you like. Normally I split this out into another variable, but I guess it's not actually necessary, so why don't we just leave it as is? But we do want to know when this clicks. Oh, I know why I separate it out into another variable. In the off chance that these are smooth scrolling, and I'm not sure Windows ever actually does this, I've never seen it, but if like scroll state is like say 43 or something, because that's what the user scrolled to, because they had a non-clicky scroll wheel, then what would happen is this would change, and so this would change without us receiving a notification that it changed. So I mean, we could go around doing that, and then we'd have to be like while and stuff, but
That's wasteful.
Yeah, that's no good. So yeah, that's the reason that you want to split this out into another thing. So we have scroll state and zoom level. And so
okay, now we're caching. Now we're going to cache the zoom level with everything else, right?
Yeah. So we actually not the zoom amount, but the zoom level. So
right.
And we could leave it in the same units as scroll state, but I usually just be like, well, like 2f, and just be like zoom level +1, zoom level -1. So I've added in that extra steps to ensure that we're always on one of those clicks. So we've removed the ability to smooth scroll, but that's the code for that's more complicated if you want to do it nicely. Make sense?
Okay. Yep.
So let's just check we haven't broken anything first. well, I broke something. Zoom level, zoom, scroll state. Yeah, okay, I see what I broke.
Whoa. Oops.
And now here's the interesting thing, and that is I can't see what yours is doing to try and intuit what's going on.
Yeah, I know. I'm
Did
just
you have
trying
the
to
same
think,
problem I did?
I just.
Yeah, so you're still getting, yeah, this is what I did as well. It's like zoom out based on the zoom level. So we actually want to change that function here.
Not quite sure what I'm doing anymore.
So, okay.
No, it's just
yeah.
Oh yeah, you can't see. You're right. You can't see what I'm.
Yeah. I can't see yours.
Okay, hold on. Let me just double check. Can I just double quickly just see your zoom amount? Okay, that looks normal. I'll just make it stylistically the same as yours for no reason.
Oh, it's
and then,
right.
Oops.
I made that a double, so it's not like because power takes double. There's no point in making that a floating point, because it'll be like, all right, we'll cast this integer to a float, and we'll do it the operation in single precision floating point, and then we'll cast it up to a double precision floating point. By doing just double straight off the bat, we do that in one step.
Oh, makes sense. Oh, well, compiler probably does it for you anyway, right? If I did that in Liner.
I'm not 100% sure, but I suspect it's more likely than not that it would actually go through single precision floating point.
Oh, interesting.
Because if that's what you're asking.
So my scroll state is actually not being assigned to anything anymore. My update method is not being used for anything.
Oh, I see what you're doing. Yeah, there's your bug. So we talked about that, but I don't think you actually went and changed that.
Yeah. Right. Okay. Hopefully that's all it is.
So I think that should be everything for you. So let me know if that matches what it should be.
Yeah, I'm back in the saddle again.
Okay. So we basically got back to where we were, and now we're in a position where we're actually getting these events. So let's put in the equivalent of this little sucker, and I think this is just a straightforward programming thing. We have yeah. So we already have some scale. So this is actually, this is why this is interesting. We have some scale amount already. Like this could already be scaled like to, well, this is why we use the pen. Okay, so this could already be scaled by like 2x. And then we come out here and this is going to, what's after 2x? I think it's
3x.
Is it 3x? Because we're on a power. Let's say it's 3x. I think it's slightly different. It must be 3. I don't know. It must be 3x. So like the scale, we want to change the scale. So the amount of scale in this step 2, if it's going from 2x to 3x, is actually 1.5x. So this amount of scale is, these ones, which is these ones, which we're doing, which is these ones. So, and fortunately, we know that we can just ask for this value because it is zoom amount, well in that case it's 1, because we're zooming out by one step, and we know that our power function just works like that. If we had a different system, we might need to do like zoom amount old. I think over. Is it over? Whoops. and I say it's over, I could have this backwards. I need to think about it. Zoom amount new, and that would be our scale. Hopefully I don't have those reversed. I don't think I do. Does that make sense?
Yeah.
Yep.
I mean, yeah. Okay.
Cool.
Yeah, this is the delta between the two zooms, the one we're on and the one we're going to.
Mm-hmm.
Just that, yeah.
In fact, maybe we should do it that way. Let's give that a go that way, because then if we go ahead and we change this function, say we like make that say a lookup, it's like, you know, if zoom level equals 1, turn 0.5. If zoom level equals 3, you know, return 1.5. Or that's actually bogus. I think it should be that, or something like that. You know, if we made that a lookup or something, this would still work. So let's do that. Equals zoom amount.
Whoa. How am I in Pong? Oh, just switch to that. Right. I'm a little lost. I'm just going to find where I was.
That's all right.
I'm looking for method. No.
Yeah, I did. I'm sorry, I did have that backwards now that I think about it. Now that I actually now that I'm not talking and drawing at the same time, this should be, speaking of zooming, there we go. This should be new, this should be old. No, yes, yes. Yes, it's that. It's definitely that. 100% definitely that.
Maybe increment the zoom level. Yeah, okay. I mean, this is straightforward when you read it, getting those.
Yeah, so I mean, you got to think about the maths, and I mean, to a certain extent, you can like inline some of this stuff, but writing it out like this makes it really clear what's going on. So now all we have to do is like slap together the code that does this business here. And because, you know, this is the same as this, we can just do this as a vector equation. So.
Oh, okay. That was good. Yeah.
So we want to translate the whole view by what we had there was negative cursor times scale plus cursor.
Right, that's just the old translation. Yeah.
So this matches.
Oh, yeah. Okay. So yeah, no, that's okay. It's just right there in plain sight now.
And then all we have to do is do that. And if we haven't made any mistakes, this should work. And aside from the zoom level, we'll slap that in there. And like this,
we don't have to use matrices here because we've already scaled them.
Well, like I was saying before,
for that.
This is where the matrix magic happens.
Yeah.
And these are the operations we have. So we have to come up with a way that will fit into that system.
Cool. Now we just have to go backwards now.
Yeah,
oh, you've already done it.
I've just slapped that in because that's just a copy paste and just change the zoom level from I'll match yours.
Right, to minus.
And so like this bit of code duplication, like that's something that you wouldn't really care about. It's like it's right next to each other. You can tell that that's duplicated. someone reading through this is going to have no trouble whatsoever with that.
Yeah.
So
okay, cool.
Let's see if we've got this right. Fingers crossed.
Mine blanks out. I must have done something wrong.
I've done something wrong too. So now this is the bit where we debug it and figure out what we've done wrong. Because clearly, so it's possible that I have made a math error. It seems almost right.
Mine is absolutely wrong.
Okay, well let's try and synchronize up, seeing as I can't see what yours is doing.
Sure. I'm just going with extra difficulty today for no reason. That's fine. My fault. Okay, so I'll just make mine the same. So float, 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 and then new over old, and then cursor vector 2 ms, and then translates negative times scale plus positive camera plus the translate. Okay, I don't see anything wrong with that.
Okay, so the first thing I will probably guess is that maybe I was right the first time. Typing would help. And I'll make sure I'll copy that into the second part too. And I'm just going to just randomly check here because, yeah. So something has gone horribly wrong. It's now up to us to find out what that is. So it's not that, because that's made it worse, I'm pretty sure.
Okay.
So
maybe it's not in the update and it's in the camera itself, what we're drawing.
Camera position, translate, zoom.
Well, we're
okay. Well, first of all, you're doing your translate before the scale, so switch that around.
What do you mean doing my?
So the first operation is yeah.
That's weird. How did I? That's dumb. That's just a bad error. Yeah. Okay. Yeah. I knew that it was before that. I don't know how I got it that way. But I still, like, you can't see it, but I still make one click up and everything disappears. Well, that's an interesting problem.
Okay.
Zoom, camera. I have the same code as you in get camera. For sure.
So, okay, get camera is the same.
Yep.
So it must be the update.
Yep.
And it's possible. It's possible. Yes, it's possible we've made a mass error, and by we I mean me.
I'm definitely making it too. All right, so get camera and then update. Scroll states greater than equal to minus less than equal to minus plus, and then the 3. I mean, this all looks exactly what looks like how we thought it would look.
Okay, so let's. I'm just going to try. Unfortunately, like, this is one of the things. I'm going to try what I said the first time, and that is this, because I know that this function is actually this way around. So it works the first click for me, and it sort of works in subsequent clicks, but then it gets a little shaky. Maybe I have, yeah, maybe I've made a mistake with
I still don't even get the one click. I don't even have the
that's weird.
decency to have the.
No, I see what you've done. You've got a multiplication here.
Oh, wow.
And that should be a
wrong symbol. I was thinking matrices when I wrote it.
So it should be cursor
Like,
times scale plus cursor. But I'm just wondering if I've actually made an error here, because I worked this all out on paper first, and it's possible that I have made an error when writing it out on paper. So I'm just going to try something here real quick.
oh, I see the behavior now that you're referring to.
Yeah. So you can see that we're close. And I'm just wondering if, like, it gets worse when you zoom out. So I'm just wondering if I should actually be working in like world space or
If you
something.
zoom in and out, sort of like rhythmically, it translates to a different position each time. It tells me that like we're accumulating too much, or like if you just go out, out, in, out, in, out, in, it drifts towards the origin. So we're not going back to where we were before. Like the translation isn't translating all, like there's the floating point slop. At least for me.
That's a bit frustrating. Unfortunately, I'm doing what the thing that I'm doing now, which is trying a bunch of stuff just to see if I can narrow it down, is actually not what you should necessarily do in this situation. Although I seem to have solved it. No. And I think geez.
Why do you say it's not a good idea to play whack-a-mole?
Because it's far better to understand what the problem is than just sort of try and stab at it. Because then, well, not only do you get a better understanding of what's going on, you can figure out like how to fix it. So, there's an alternate way of doing this, and maybe we should explore it. Because I'm sure that what's happened is I've just got this maths wrong. The concept is correct, and I mean we had it working.
With our target value, sure.
Yeah, we had it working with the target value. So I'm just trying to think about why that's the case. Because the other thing.
Well, why don't we do the translate, scale, and translate? Because we're not doing that here. We're doing the scale and translate. I guess because you built it in, you compressed it into the two. So I guess that doesn't matter. But what if we just keep the target separate and do the 3 times thing and get it to that point?
So the reason is because we don't, unless we like keep track of every target on like every click, we don't.
Oh yeah, we talked about that.
Yeah. So that's really frustrating. That's like it's like 2 maths errors in 2 weeks. I feel bad. So what we're doing is we are translating to there. That translation comes after. So like we could work this out in like long form, and that is we have our camera matrix, which is like zoom x 0, 0, zoom y. That must be right. Translate x, translate y. And we want to multiply it by this matrix here, which is S X. I think we might be onto something here. S Y. Let's do the maths out properly. So can you understand what I'm doing here? I'll call that A equals that. So can you follow what I've done here so far?
Well, you're plugging in our values into the original matrices, right? Like the Z is the zoom and the T is the translation.
Yeah, so this here is the camera, and then this here is the, I guess, the operation we want to do on the camera. And we've already established that this is correct. In fact, why don't we just quickly try and prove that this part is correct to ourselves? Because I think you're onto something with what you were saying before. So let's go back to our testing thing, because like I said, we test these things are right. And so we've obviously, if we've made an error, we've missed a testing step. So we'll get rid of the interactivity for a second. We'll bring back our target, and obviously just check this works. We're zooming in on the target. So this bit of code is right. So let's see what happens. Yeah,
I
so
lost
this is,
that little bit.
no, that's all right. So this is why we want to get rid of the interactivity. So we're going to just go with constant values here for a second.
Yep. We just want to prove the math. We're going to do it ourselves.
Yep. So in fact, let's scale equals 4, just so we can change it, but we want to make sure that it is the same. So I just want to prove that this A is correct, and I'm almost sure it's right because we worked that out carefully on paper, but it's possible that it's wrong. So let's just make that matrix. New transform to D, M11 equals scale dot X, M22 equals scale dot Y. What's going on here? Scale is not a vector. X equals negative target dot X times scale plus target dot X, and then the same for Y. You're going to auto format that for me. Thank you, Visual Studio. So this transformation matrix, comment out these, should be equivalent to this operation. So let's just prove to ourselves that it is first.
For some reason, my M22 is in the private version. I don't know why. So
yeah, they're all public. Okay. They're
yeah, they are now.
Yep.
Okay.
So at least as far as my code goes, yeah, just comment those suckers out. We're doing that correctly, and then we can go back to this code and be like 0.5f, and it zooms out around this point here.
Right. So we can just throw our zoom back in and just get rid of scale.
So I'm reasonably happy that that bit of maths is correct. So that's good.
Yeah, the zoom. Yeah, the zoom is good with interactive values now.
Oh, good.
Definitely.
And I guess, yeah, of course it should be. Yeah.
Yeah, right.
Makes sense. Makes sense. Okay.
So now
So
what?
we've proved that the error is not that. So the error is actually in the conception of what we've done. And I think I've figured out what that is, which is what we're doing here. So what we were trying to do is we're trying to basically append this operation onto the camera, which is exactly what we've done. So we've got our camera matrix,
Right.
and we're just slapping that on the end. And the way we've appended it is we just shoved in the zoom value and shoved in that value, and I think that was a mistake. So let's just do the maths real quick on this one, which should be fairly straightforward. So first of all, I mean, we can just look at how we've done it, because that's the nice thing about readable source code is it's like, well, I just read it and it's like, all right, m1 times m1 plus m1. So we know that all of these 2 1s and these 1 2s are 0 anyway. So this ends up just looking like zxsx 0 0 zy sy, and then this business here looks like I think this might be a cause of our dilemma. So the existing translation, the existing camera position there gets shoved through this scaling factor. So it's actually this scaling factor there. So it's actually txzxsx plus ax, and then, you know, the same tyz ysy plus ay. So I'm happy with that. Does that make sense to you? Like, do you understand what I've done?
Yeah.
So adding on,
we forgot. We're basically saying that we forgot the scale in the affine transform.
Sort of. So adding on this a is correct. This a here, when we add it on to the end here, that's correct, which is what we were doing before. We were just blindly adding that a. What we forgot to do is we forgot to include that and that.
Yeah, right.
So if we include those, and so that's just a maths oversight, because I was, I guess, going too quickly and shortcutting the maths, which is a bad habit that I have. If we just add these in, it should make sense. Let's just code that up and see what happens. I'm conscious that I'm just conscious I have made a small error there, and that is errors all over the shop. That is actually, I did the multiplication wrong. So that gets multiplied by that one, not the completed one, I think, unless, yeah. Let me just check. AX times that. AX, that, no, yes, times that plus that, yeah. Yeah, so that's all we have to do. We have to modify the existing camera position to account for the new scaling factor. So we can do that. We know what the new scaling factor is.
Right, because, yeah, right now. This translate variable is our A, right? That's A.
That's A.
But we haven't so we also have to add.
I think that's correct.
Yeah.
Does that make sense to you? Let's get rid of the crap I was trying.
Yes, because the camera. Well, no, but, well, it does. I mean, it doesn't make sense to me because we apply the scale when we get the camera to draw. But I guess, yeah, no, I guess we have to do it here because that's what we're. Otherwise, we haven't shifted it to the origin, scaled it, and shifted it back.
Let me just check I've uncommented the camera setup. Ah, I've made a copy paste error.
But mine works.
That's good. That is good.
Now that you can see it, but it does work.
Mine works in one direction but not the other, and that's because I've made a minor bug. That's the downside of copy pasted code. So we figured out what the maths was. So that works correctly, and so we can draw a thing and zoom in on it very accurately and zoom out on specific things as well. Okay, so let's just review. So are you happy with what I've done there?
I mean, yeah, and you know, my grasp is tenuous just because of the. I mean, I know how you got that, right? I mean, I just don't. Every time I look at the M11 plus M12, it makes my eyes cross. Yeah. But I understand that we forgot the scaling when we did conceptually, that we forgot to scale it before translating it.
So we forgot to scale by the existing offset. Like,
that's right. Yeah.
Our this is all correct. This is correct. This is correct. It's just we basically got this maths wrong. We forgot this term. That's all we did.
And then when you just like did it by rote based on the other matrix math, then you just saw clearly that was missing.
Yeah, like, so all we did is say this was what the camera started with. This is the operation we want to apply to the camera, and this is like, stick this into, you know, Wolfram Alpha or calculator or whatever, and this is what comes out the other end. It's just raw arithmetic.
Right, and you even said at the beginning that you have to take TX and TOI and push it through the scale matrix. We didn't do it.
I'm not sure I actually said that specifically, because remember that we are scaling here in A. A also has a scaling factor.
Right, or in that case, you said that like I'm pointing, but you can't see me pointing. But the AX and AY would just end up being added by itself, but TX and TOI would pass through the SX and SY, and then AX and AY would pass through nothing to get on the end. So and now that you wrote it out, that's what the description of what you said is there.
Let me try and draw it out, because I think maybe this would make a bit more sense. So yeah, I don't know. It's not so bad to make errors, because it's like we can then try and figure them out and explain them. So if our camera was already like up here, like I know this is flipped to what it actually is because of, you know, is Y up or down business. But say this is our camera's translation, and we want to zoom in on a point in here. So we need to do the A business where we like, what's the best way to draw this? Basically, I think this is the case, is basically when this, oh, can I draw this in? I'm going to draw it in blue. When the camera gets like bigger, this T value here from what it was before has to change. So if this gets, I'll go back to the other sheet. If that one gets bigger, we go backwards by the bigger amount and then up by the small amount. So it's effectively, Yeah, there's a lot of components to draw out here. This is the cursor position, so that would be scale up by, no, sorry, translate by that amount. Yeah, we need to translate that amount, drawing, that amount, and then we translate back by, it's going to get really colorful real quick, that amount. So we can see that
the translation back to have a scale
overall translation
applied to it.
Just with those two that we were doing when we were getting it wrong was that plus that equals that. So it was just that. And that would, that would move the camera. So we'd have this old translation and it would add on that new translation. And so the camera would end up like out here.
Right, and that's why if you zoom in and out and in and out, it looks like it's moving across the screen because we keep not replacing the translation back to
exactly
T.
So this T here needs to get scaled. So and it would get scaled by whatever this is. And I don't think this diagram is quite perfect, but you can see that now, like this one here is now like T prime. That's the new T. And so you can see that even though I haven't drawn this very well, there's definitely a difference in the translation.
Yeah. Oh, the orange line is larger than the first red line by as much as the green box is larger than the blue box. Right?
I think so. That
yeah. No.
I'm like. I feel like this diagram is not entirely correct for some reason, but hopefully that demonstrates that why at least T needs to change.
Yeah.
So
I'll probably rewatch the video and it'll make sense the second time.
Yeah,
I believe.
We're scaling up, so T has to be scaled up by 150%. So that means that, I mean, we can keep looking at this. Like, you can hopefully see my dilemma here, because it's like, so we've scaled up by 150%. So T should actually change from T to like T prime.
Okay.
So that should be T prime. And then these vectors are based on, yeah, I think the error that I'm making is that these vectors are in the wrong space. Like the vectors that we're adding on don't actually look like that when they're in the same space. If that makes sense.
No, but that's my fault.
No, it's not your fault. It's like this. I'm supposed to be explaining this, so I'm going to try and come up with an explanation. Okay, so this is T. T is just how far we move the camera.
Yeah.
And we're zooming in. No, sorry, we're zooming. Sorry, I know why I've made a mistake. I've said we're zooming in and we're zooming out at basically the same time. This is garbage. This is wrong. So we are zooming in by 1.5.
Right.
That's our zoom
click
factor. So this has gone up by 1.5x. So our view, it started, let's just pretend we're zooming, say, a point in the middle or something. It started like here. If we zoom in by 1.5, the amount of stuff we see is actually going to shrink.
Yep.
Yeah, so it's just a bad diagram. Ill-conceived. And so hopefully you can see that if this is in the middle, these arrows were actually fine, I think. If it's in the middle, what happens? We add we add the scaled amount of the cursor position. No, we subtract the scaled amount of the cursor position. So we subtract that, or add that, because that's the cursor position relative to the screen. No, it's in world units. Yeah, so that actually, yeah, so this is the cursor scaling, the amount we add based on the where the cursor is actually not represented in this space here. It's actually off in its own space. It's
yeah, okay.
It's that in one case, which gets scaled to that. If we're zooming in, it goes to 1.5, so it's actually that, and then the other direction it gets added on like that, and you get this sort of vector here. I was trying to figure out why?
The little green arrow is the amount that we were originally translating.
So this is our A. This is A here. Is this?
Yeah, that's us tacking on A, but forgetting to do that S against T, which is T prime.
So now I'm happy with this T business, and now I'm unhappy with this A business. I'm like, what have I done? What have I done here?
I mean, it's enough to say that T prime was what we needed.
Yeah.
To add to the camera position, but we only added T.
Yeah, like I guess I'm trying to relate these two diagrams, because so this is our our A diagram, and that's right. And now we've got this T diagram up here, and we know that that's right. It's like, how have I messed up the relationship? So, like we know that if A is 0, it's going to be there. Like if our cursor position is 0, it'll be there. If our cursor position is like there, let's say, and we want to zoom around that, well, it's got to be the center, because that's what we drew here. Oh, sorry, I know what it is. Yeah, I know what it is. So this is the thing. This is why it's good to like program these things out and visualize them, because this scaling factor here, or sorry, the one that's going in like that, the way I've drawn it, is not 1.5. So
like 2.
Something like that. Yeah, because you can tell, in fact, that like that width there is like half that width there, and so the amount that T would go if it was 2, let's say it's 2, because I've already drawn it like that. It's like, okay, and now we can figure out why we had it wrong. So it's like T would be 2, it would be out there, and then you subtract. Here we go. Now we've got it. There's our A. So now we know what's going on. Yep, that makes sense to me. Does that make sense to you?
I think so, yeah. Yeah, just in terms of what the mistake we made, we had T and then we added A, but we didn't get T prime to get to the spot that we were supposed to be translate. So we always were off, always translating by like moving it a little bit less than we needed to, and it was going in the wrong place.
So
that's why the more zoomed in, the more progressively worse it got, because the position was a lot more and more further away because we kept making the error.
Yes. So this is if we add A without without
Without,
changing
yeah.
t, we end up with the screen is now looking at that bit of space and it's wrong.
Right. Yeah. Yeah. Yep.
Okay, so that's good. That's a bit of maths debugging, which I think helps. So I think we'll shut it down for today.
Yeah. Well, I'm good. I'm happy with what we have.
Okay, and I think so. That's going to probably be the end of like the translation stuff, like the matrix stuff and the camera stuff. And so I have some ideas for what we'll do next week and the week after, because I want to sort of move on to some new topics now. We basically have this we have cameras licked, we have transforms licked, we know we've drawn some diagrams, we know how all that works. So yeah, I'll stop recording and then we can have a chat about what we'll do next week.
Cool.
All right.
Thanks.
Thanks for watching, YouTube people.